Hello and welcome to Autumn Math. In this edition of Autumn Math, we're going to talk about linear inequalities. We're going to handle the lesson on linear inequalities and we'll include a little bit of practice. All right, so let's talk about what a linear inequality looks like. A linear inequality can be written in the form ax plus b is greater than or less than or greater than or equal to or less than or equal to something, where a and b are real numbers and a is not equal to 0. So in this area here, I write the greater than symbol, but it can really, and also in the definition, greater than or equal to. But it can also be greater than or equal to, less than, or less than, and equal to. So a solution of a linear equality is a value which, when substituted for a variable, results in a true statement. All right, lots of words for you. Let's take a look at what that might mean. So I have a linear inequality, 3x plus 6 is greater than 12. And I want to figure out what a solution could be for this linear inequality. Now, there might be one solution, or there might be no solutions, or there might be many solutions for linear inequalities. In this case, we have solutions that are many in number. So 3x plus 6 is greater than 12. I can see that if I plug in a value of, let's say, 10 for x, let's say a solution is 10, I will get a true statement. So 3, if I plug in 10 for x, plus 6 is going to be greater than 10. So 3 times 10 is 30, plus 6, 36, ends up being greater than 12. That's a true statement. So I know 10 is part of the set of solutions for this particular linear equality. Compound inequalities consist of two inequalities joined by and or. Okay, so what might that look like? Compound inequality, so I take my prior linear inequality and I add another one to it. So 3x plus 6 is greater than 12. And I can say either that inequality is true and 2x plus 5 is less than 3 is true, and then solve for x. Or I can say 3x plus 6 is greater than 12, or 2x plus 5 is less than 3. And those two words are very important for the solution, and we'll talk about what that might look like right now. Okay, so first we're going to solve with a linear inequality. We're going to isolate the variable with algebraic transformations. That's something that we've been handling over the past couple of sections. We're going to use the properties of equality to solve. And you would handle it very similarly to how you would handle an equation where the inequality symbol just changes to an equal sign. And we'll go into, in later sections, we'll go into some issues that you might run into with negative values and how to manage having negative values or coefficients for the variable in a linear inequality. So here's my example, 3x plus 7 is less than 19. What we're going to do is we're going to subtract 7 from both sides like we would in a regular algebraic equation where we're solving for x. So I subtract 7 from both sides. Now I have 3x is going to be less than 12. I'm going to divide both sides by 3. 3x divided by 3, 12 divided by 3. Now I see that x is going to be less than 4, and that is my solution. Okay, so let's talk about the compound inequalities. As I mentioned before, let's handle a couple problems and let's see what we can learn about what the differences are between compound inequalities between that have and the compound inequalities that have or. So we're going to tackle the or compound inequalities first. So to solve for a compound inequality with or, we're going to do the same thing that you would with just a singular compound inequality. We're going to isolate the variable and then solve. So in this case, I have my example, it's negative 10 is less than 3x plus 5, or 2x plus 4 is less than or equal to, less than or equal to 8. So I'm going to rewrite the equation, subtracting the left-hand side. We'll go through that inequality first. Negative 10 minus 5, is not multiplied by 5, is less than 3x plus 5, and again, minus 5, not multiplied by negative 5. And I end up with negative 15 is less than 3x. I divide both sides by 3, and I end up with x is greater than negative 5. on the left-hand side for that inequality. Now, if I were to have a coefficient, let's say, for example, that's a negative value, negative 3, if I ended up with negative 3x is greater than negative 15, I would divide by negative 3. And whenever you divide by a negative number in an inequality, you need to change the direction of the inequality sign. So if I were to divide, in this case, this is just as an example, by negative 3, I would end up with not x is greater than 5, but x is less than 5. So I had to change the direction of the inequality. Okay, so we're gonna cover that in a later section, but for now I just wanted to let you know to keep your eyes and ears open as we run through the problems when we tackle another problem like that in a subsequent chapter. Okay, so on the right-hand side I have 2x plus 4 is less than or equal to 8. I'm going to subtract negative 4 or 4 from both sides. Again, in parentheses, I just do that to separate the values. The parentheses do not stand for that value multiplied by the value in front of the parentheses. So 2x plus 4 minus 4 is less than or equal to 8 minus 4. I simplify that further. 2x is less than or equal to 4. Divide by 2, and now I'm left with x is less than or equal to 4. Okay, now I have these two solutions, x is greater than negative 5, x is less than or equal to 4. With a compound inequality that has or, solutions can be any value which satisfies either simplified linear inequality. So it helps to draw a number line. So that's what we're going to do. For the first one, we're going to highlight the area that satisfies the first inequality, x is greater than negative 5. Okay, I draw my opening here, this large circle, it should be open, and anything that's greater than negative 5 satisfies this inequality. Okay, in the next section here, next to inequality, I have x is less than or equal to 4. Now I'm going to bold in this area, and then I'm going to highlight everything that satisfies this inequality. And I'm left with a solution which has all real numbers. Because remember, it can be either, it can meet as long as the solution, the value for x is a solution for either inequality, then it meets the criteria for the compound inequality. So you can see that in this case, I can choose any number, and any number will either be green or blue or green and blue. So any number or all real numbers will satisfy this particular compound inequality. So we know how to handle compound inequalities with or. Let's talk about how to handle compound inequalities with and. Right, to solve for a compound inequality with and, we're going to do the same thing that we did before with this singular inequality. We're going to isolate the variable for each inequality and then solve. Right, so in the example I have 2x minus 1 is less than or equal to 7, and 4x plus 3 is greater than or equal to 7. I simplify that by, on the left-hand side, we'll go through that inequality first. 2x, I add 1 to both sides. Now I'm left with 2x is less than or equal to 8. Divide by 2, and I have x is less than or equal to 4. On the right-hand side, I start with 4x plus 3 is greater than or equal to 7. Subtract 3 from both sides. 4x is greater than or equal to 4. Divide by 4. Now I am left with x is greater than or equal to 1. Okay, so now I'm going to go through the process that I went through before, where I highlight on a number line what my answers are. And so in the first inequality, x is less than or equal to 4. I'm going to write up top here, this is going to be in blue, x is less than or equal to 4. And it includes 4, by the way, because there's an equal to sign. So I'll just make this a dot. In the second one, it's going to be x is greater than or equal to 1. Okay, so here's the dot here. And I draw my green arrow going to the right. So the answer is going to be the portion that satisfies both inequalities, not either one, but both. So we can see that what satisfies both is anything in between, or anything that's going to be inclusive of both the blue and the green line. So it's going to be from 1 here, inclusive of 1 because we have that equal sign, and 4 and inclusive of 4 because we have that equal sign here. So anything between 1 and 4, that's going to be your answer. And you're going to write that as x is greater than or equal to 1, but less than or equal to 4. Okay, so remember, if you have or, it's going to be either or. In this case, it would be all real numbers if I said or. And in both, it's got to be that portion that is both, that includes both the blue line and the green line, but not either or. Okay? And that's it. We'll go through some problems in the practice section. So I suggest that you continue on with the YouTube video for the practice for chapter 1.6.